Alrighty, hello everyone. So I'm so sorry. It looks like there was another issue with the recording from last week. I guess only half the screen was showing. I don't know why that happens, but I am going to re-record now so you can see and get everything down. But yeah, so let me go ahead and share my screen and we will hop on into it. So again, this is discussion 9 and we are looking at spirometry. So we have 9 and 10 before exam 4, and it'll be looking at the respiratory system. So we're going to kind of start with the basics today. So here's an overview of the respiratory system. We have all of these airways and cavities and tubes and channels that are going to carry lungs from the outside atmosphere, either through our nose or our mouth and into our lungs. Now, inside of the lungs, we have a few different branches. We have the bronchi, which split off into bronchioles, which split off into even smaller tubes called alveoli. Alveoli are the main functional units of the respiratory system that we will be looking at very closely during this unit. So pretty much all of the other structures except the alveoli just conduct air into the alveoli. The alveoli are these grape-like looking structures. They are covered in capillaries, and that's where we're actually going to see gas exchange. So that's where we'll see carbon dioxide diffuse out of the blood and into the airways, and oxygen diffuse from the airways back into the blood. And again, those are the alveoli where we actually have respiration. The rest of those structures, the nose, the mouth, the trachea, or the windpipe, and the bronchi, those just deal with getting air to the alveoli. So when you are wanting to determine lung function, just like if you wanted to determine heart function, we have a device called a spirometer, just like we have an EKG for the heart. The spirometer works by using a weighted bell and a tube that you hold or that you have in your mouth, and the person directing the test will tell you to breathe in specific patterns. So they'll say, breathe normally. And when you're breathing normally, that bell will move up and down in the water, creating this graph. Then they'll tell you to breathe really hard. So they'll tell you to do a really hard exhale, as hard as you can. Get all the air out that you can. They'll also maybe tell you to do a really big inhale to see how much air you can bring into the lungs. And again, it'll be measured on this chart right here. We call it a spirograph. So this is what a usual spirograph would look like. We have a couple different, chart segments here. And so let's work through them. So when looking at a spirograph, we will always have 4 volumes and 4 capacities if we're looking at the standard test. So the volumes are very important to understand because once you understand the volumes, you'll be able to understand the capacities. So the first volume we have is tidal volume, and tidal volume is sometimes called normal breathing, sometimes called quiet breathing, because it takes no extra effort. This is probably what we're all sitting in right now, unless you just ran up a flight of stairs or you're really nervous or something. But other than that, we should just be taking a normal inhale, a normal exhale, a normal inhale, a normal exhale. Again, that is called tidal volume. It's about 500 milliliters. Then we have inspiratory reserve volume. So this is the max volume of air that you can inhale. So if we were taking our test and they said, okay, take a really big inhale, that's going to be the inspiratory reserve volume, the max amount of air that we can bring into the respiratory system. The last 2 we have are the expiratory reserve volume and the residual volume. So expiratory reserve volume would be them telling you to exhale as much as you can. So, however, even though it feels like you've breathed out all the air that there is to breathe out of the lungs, there is still quite a good amount of volume of air left over. And that's what we call residual volume, the volume left in the lungs after a full exhale. So if you think about a balloon is kind of hard to inflate at first. Like when you inflate the balloon, normally you'll stretch it, kind of get it loose. But that first inflation of the balloon is hard to get it expanded. But once you have the air in there and it's expanded, it's easy to add more air, take a little out, and all of that. So if we think of our lungs like a balloon, if we were to fully collapse them and remove all of the air, it would be really hard to fill them up again. So we always leave some air, about 1,000 to 1,200 milliliters of air in the lungs, so we can easily expand and contract without having to fully refill. So those are the 4 volumes: tidal volume, normal breathing, quiet breathing, inspiratory reserve volume, the max inhale, expiratory reserve volume, max exhale, and residual volume, the volume left over after a full exhale. Now we have our capacities. So we have 4 capacities. We'll start with vital capacity just because it's pretty important. So vital capacity is looking at how much you can inhale plus normal breathing and how much you can exhale. So vital capacity is looking at our total lung function. It's looking at how much air we can breathe in and how much air we can breathe out, including that tidal volume air. Then we have total lung capacity, which is looking at the entire volume of air in the entire respiratory system. So that's including all the way to your max exhale, even to the bottom of residual volumes. That's looking at the total amount of air in the respiratory system, whereas vital capacity is looking at the amount of air that we can voluntarily move in and out of the respiratory system. But you do need to notice that vital capacity does not contain residual capacity because we cannot voluntarily exhale that residual volume. If you try to, if you go, your lungs don't collapse, there's still air in there. It will be brought back in. So vital capacity, think vital voluntary. That's what we can move in and out. Total, it contains that residual. Inspiratory reserve capacity is looking at the inspiratory volume plus the tidal volume, so just the amount of air that we can voluntarily inhale. And functional residual capacity is looking at the amount of air that should be left in our lungs whenever we're just quiet breathing or normally breathing. So here we're breathing normal, so we should have this amount of air left over in the lungs, because it's not like you fully exhale each time you breathe normally. It's not like you go, you normally just breathe out a little bit. So functional residual is the amount left over during quiet breathing. So make sure you understand the volumes and the capacities. You'll either be asked to label this on the exam, possibly explain it. So I would definitely understand the spirograph, and it is quite simple. So just work through it 2 or 3 times and you should have it down. So again, looking at the spirogram one more time, this is just a different illustration of it. But of course, number 1, that's looking at normal breathing, which normally we call tidal volume. So tidal volume, quiet breathing. 2 is that max exhale, that is our inspiratory or max inhale, which is our inspiratory reserve volume. 3 is looking at that max exhale, so expiratory reserve volume. And 4 is looking at that volume left over that we always keep in the lungs, which is that that residual volume. Looking at the capacities, 1 and 2 is going to be that inspiratory capacity. So from the bottom of tidal volume to the top of expiratory or inspiratory reserve volume, that's going to be our inspiratory capacity. 3 and 4, so from the bottom of our tidal volume to the top of 4, that's our functional reserve capacity. So that should be what's left over during quiet breathing or normal breathing. So from here to here. Then we have 1, 2, and 3. So from here all the way down to here, that's the vital capacity, the amount of air that we can voluntarily move in and out of the lungs. And lastly, total lung capacity is all of them. So normally lung capacity is about 6 liters or 6,000 milliliters, but it definitely ranges per sex and body composition. So I wouldn't worry too much about memorizing these values because they do vary person to person, but they do give you a rough estimate on how much air will be in each capacity and volume. So now hopping into question number 1, we're looking at 2 zones of the respiratory system, the conducting zone and the exchange zone. The exchange zone is also sometimes called the respiratory zone. So the conducting zone, its function is exactly the title. It is conducting air into the alveoli. So the conducting zone is all of the structures, the nose, the mouth, the trachea, the pharynx, the larynx, all of that. Just its main function is to conduct that air that we breathe in from the external environment to the alveoli. The alveoli are the exchange zone, where we see the exchange of carbon dioxide and oxygen. So in more advanced classes, you will learn that the respiratory bronchioles, a type of bronchiole, deals with exchange as well. However, for this class, you just need to focus on the respiratory or exchange zone containing the alveoli. So the alveoli are, again, these grape-like structures covered in capillary beds, and they are made of a single layer of epithelial tissue. All of those other structures don't deal with exchange because they're anatomically just too big. They have multiple layers of tissue. They'll have smooth muscle, they'll have, cartilage, connective tissue, other structures that aren't suited for diffusion. That simple epithelial tissue that the alveoli is composed of makes way for simple diffusion. So we need to be able to simply diffuse oxygen into the blood and carbon dioxide out of the blood. That needs to happen quickly, breath by breath. So that's why we use the alveoli and not like the trachea or the bronchi or any of those other structures to do that exchange. However, even though the exchange happens at the alveoli at the very bottom of the respiratory system, air still remains in those other structures. And that air that is remaining in the conducting zone, we call it dead space air. So dead space air is the air that remains in this area of the respiratory system, whenever we breathe. So luckily, dead space air can be calculated very easily. So for every pound of body weight is 1 milliliter of dead space. So if you're 200 pounds, you'll have 200 milliliters of dead space. If you're 150 pounds, you'll have 150 milliliters of dead space. If you're 100 pounds, you'll have 100 milliliters of dead space, and so on. So for every pound of body weight, we will know the volume of dead space air. So let's actually work on solving one of these questions with that knowledge. So we are asked for a normal resting breath in, what volume of air is inhaled? And here is what we are given. We know that normal breathing is the same thing as tidal volume. Therefore, we can match those up and we get 400 milliliters. So if you're ever asked for a normal breath, what is the volume of air inhaled or exhaled? That will be your tidal volume. So normal breath, that's when it's important to really understand that tidal volume is normal breathing, and that's how you can match those up. Then we are asked how much of that air is going to remain in the airway, or how much will be in the dead space. So we know that for every pound of body weight, we have 1 milliliter of dead space air. So that's why it's important to understand that conversion of of body weight to dead space, because there we see we are given the weight, and therefore we can calculate the dead space volume. So this person is 120 pounds, meaning they have 120 milliliters of dead space air, or air that's remaining in their airways. You can simply divide this by the total amount of air that we are inhaling to get 30%. Lastly, we're asked how much of that air will enter the alveoli. So this is real simple algebra. We're just going to subtract the dead space air from the total air inhaled, and that will give us 280 milliliters. About 70% of that air is entering the alveoli. So again, tidal volume, dead space, body weight conversion, and then just subtract 120 from 400 to get that last value. So this question goes along with the last one, and it's kind of the same thing, just worded a little differently. But what we see is that that air that enters the alveoli is going to be well oxygenated, whereas the air that was in the airways is oxygen depleted. So when we look at the volume of air that is then oxygen depleted, we have 120 milliliters. So that 120 milliliters that was in the dead space, that is oxygen depleted air. The volume of the air that we inhaled and entered into the alveoli is again that 280, that leftover from the calculation we did before. So 70% of that air is oxygenated. So 70% enters the alveoli, and then 30% or 120 milliliters is oxygen depleted and remains in those airways. So now we're going to kind of look at the environment of the alveoli in the lungs and what happens from one breath to another. So there is a lot of word blah on here, but the main thing that you need to understand is that each breath, almost 90% of the air in the airways remains unchanged. So the alveoli environment is very stable. Remember, our body works through homeostasis, and homeostasis is maintenance of internal stable conditions. So we do not want to change the molecules in the lungs too much. We want to keep that oxygen level relatively the same. So per breath, we only take about 13% of new air in. We absorb about 70% of oxygen from inhaled air. And when you look at inhaled air, the external air in the environment, it's about 20% oxygen and 80% nitrogen. I know some of you are probably thinking, isn't there carbon dioxide in the air? Yes, but a very, very, very small percentage. If we carried this out, it would be about 20% oxygen, 79.06% nitrogen, and then 0.04% carbon dioxide. So there's a very small amount of carbon dioxide that actually remains in the air. And we're not going to worry about that for this exam. But you do need to know that there is about 20% oxygen in the external air that we are breathing in. If you look at the pressures that is going on there, we know that at sea level, the pressure is about 760 millimeters of mercury, and about 20% of that is 160 millimeters of mercury. So oxygen accounts for about 20% of the pressure of inhaled air. So I don't think that you're going to need to do this calculation. However, if you were to check the O2 pressure that happens during inhalation, this is how you would do it. And I don't believe that you will need to do this calculation either. So don't worry about these two. The main thing you want to take away from this slide is that from breath to breath, the air in the lungs remains pretty much the same, only about 13% of it is changing. And then also, I think you should know this 20% of oxygen and 80% nitrogen in external air. Nitrogen is an inert molecule, meaning that when it comes into the body, it does not do anything. So lastly, we have two equations that you do need to memorize for exam 4. So make sure you have these equations memorized, and they're pretty simple. So let's walk through them. First, we have total pulmonary ventilation, and then second, we have alveolar ventilation. So total pulmonary ventilation is looking at the amount of air that we bring into the respiratory system, whereas alveolar ventilation is looking at the air that we just bring into the alveoli. So total pulmonary ventilation accounts for all the air from the nose, from the nasal cavity, the trachea, and the dead space to the alveoli. Alveolar ventilation just looks at the air that reaches the alveoli. So alveolar ventilation will always be smaller than total pulmonary ventilation because we're going to be subtracting that dead space volume. So when we're given a respiratory rate of 13 breaths per minute, we can multiply that by tidal volume to get our total pulmonary ventilation. And then to calculate alveolar ventilation, we take that respiratory rate, multiply it by the tidal volume, subtract that dead space air, and that will give us our alveolar ventilation. So make sure you have these two equations memorized for exam 4 because they will be important. But yeah, that's all I have for y'all. We haven't gotten too deep into respiratory and lecture yet, so I'm not going to overwhelm y'all. But that's the important things that you need to understand for this discussion worksheet. And if you have any questions, feel free to shoot me an email. Thank y'all so much, and I will see you for carbon monoxide poisoning next week.